A storage container is shaped like a rectangular prism. The volume of the container is 1,360 cubic feet. The area of the base of the container is 160 square feet. What is the height of the container? So I need my handy dandy reference material because I'm solving for volume of a rectangular prism. So I'm going to look in the volume section for prism. Volume is big B times H. Big B is the area of the base. So the formula is V equal to big B times H. Okay, so in this problem here, they've told me the volume is 1,360. So I replace the V with 1,360. They have figured out the area of the base for me. It's 160. What I don't know is the height, so I leave the height as my variable. To find the height, I solve the equation. I divide both sides by 160. The 160s divide away. I can divide by 10 real fast. So to find my height, I need to know how many times 16 can go into 136. Okay, so 16 times 8 is what I'm going to start with. So 16 times 8. All right, so 6 times 8 is 48. 8 times 1 is 8 plus 4 is 12. So that's 128. So I'm going to say 8 times. I'm going to subtract my 128. I'm going to add a decimal and a 0. Going to bring my decimal up. Going to bring my 0 down. 16 will go into 80 5 times because 16 times 5 is 80. So 8.5 is going to be my height, which is answer choice C. If you are not comfortable doing it that way, another way that you can do this is you can have your formula here, and you can guess and check, all right? So you can multiply the 160 by the 8.5 and see if it's your 1360. So 160 times 8.5, that's 0, that's 30, that's 8. Add a placeholder, 8 times 0 is 0. 8 times 6 is 48. 8 times 1 is 8, plus 4 is 12. Add that all up. Put my decimal in, which is the 1360. So if I use 8.5 for my height, okay, that equals to the 1,600, which equals to the 1,600 for the volume. So this is balanced, so this is correct. Okay, this one has an answer choice of not here. Do not ever guess the not here. Only use that if you have made sure that none of the other answers work. All right, number 11. Walter and Brian each have a CD collection. The number of CDs in Walter's collection can be represented by X. The number of CDs in Brian's collection is 3 times the number in Walter's collection. The total number of CDs in both collections is 144. What is X, the number of CDs in Walter's collection? Okay, so we have Walter and we have Brian. Walter is represented by X. Brian is 3 times the number of Walters, so if Walter is X, Brian is 3X. The total number in both collections is 144. So if I add them together, they equal 144. This gives me an equation that I can solve. 1x plus 3x gives me 4x's. The 4x's equals to the 144. Okay, I divide both sides by 4. So I'm going to divide 144 by 4. Okay, 4 will go into 14 3 times. Subtract, bring down my 4. 4 goes into 24 6 times. Nice and even, so that's 36. So x is equal to 36, and x is representing Walter. Okay, and the question is, what is x, the number of CDs in Walter's collection? That would be 36. There are 40 houses in a neighborhood. Company X provides electricity to 1/8 of the houses. Company Y provides electricity to 2/5 of the houses. Company Z provides electricity to the remaining houses. In this neighborhood, Company Z provides electricity to how many houses? Well, there's 40 houses. Company X is 1/8 of those. So I want to know what is 1/8 of 40. Okay, so I'd put my 40 over 1 and I would just multiply. 1 times 40 is 40. 8 times 1 is 8. And 8 will go into 40 5 times. So 5 people or 5 houses are provided by Company X. Company Y is 2/5. So 2/5 of 40. Put my 40 over 1. 2 times 40 is 80. 5 times 1 is 5. And 5 can go into 80 16 times. So 16 people are 16 houses are represented by Company Y. The rest are Company Z. So if there's 40 houses altogether, I need to subtract these off. So 5 plus 16 is 21 people. 21 people are being served by X and Y. 40 minus the 21 is 19. Okay, so 19 houses are going to be provided by Company Z. All right, number 13. An advertising banner has 4 sections as modeled below. 2 sections are congruent trapezoids, and 2 sections are congruent right angles. So since they're congruent, it means that they equal to each other. Well, on my handy-dandy reference material is the formula for area of a triangle and area of a trapezoid. And the area of the trapezoid one is a little bit weird, kind of gives y'all problems. So if there's another way to work it, let's work it that other way. So this is the trapezoid, this is the trapezoid, this is the triangle, this is the triangle. Okay, but when I look at this picture, I see one great big triangle, or I could even half it. So instead of messing with the trapezoids, I'm going to say, let's find the area of each of these triangles. Okay? So, and it wants to know which measurement is the best estimate of the area in the banner in square meters. So, I'm going to go ahead and round so I'm not having to deal with these fractions. Okay? So, 1 3/4 is almost 2 meters. So, that's about 2 meters. And 1 1/4 meter, that's about 1 meter. So I'm going to use 1 meter. All right. Oh, just kidding. We don't have to use that one. We're going to, because our height here is 2. The height is 2. So we're going to use 2. And we're going to use 2 from here to here. And then from here to here is 1. So if that's 1 from there to there, from here to here is 1. Okay. So for my base, I'm going to use 3. Because I'm going to add 2 plus 1. All right, so what I did is I'm using this height of 2, and I'm using a base of 3 because I estimated the 1 3/4 to be about 2, and then then this is 1 meter, and 2 plus 1 is 3. So since I'm going to find the area of a triangle, that is A is equal to 1/2 base times height. So this is 1/2 times my base of 3 and my height of 2. So 1/2 times 6 is 3. Okay, so this triangle here has an area of 3. All right, that's half the figure. This triangle here also has an area of 3 because they're congruent. And 3 plus 3 is an area of 6. So instead of dealing with trapezoids, I just split the shape up into 2 triangles and made it a little bit easier.